Okay, hello. So we're now on our first topic for the final period, so which is about the Wallis formula. So from prelims and midterms, so we cover the different techniques in finding the integral of a given function, but all of those things are pertaining to indefinite integral. So meaning, so we evaluate it, okay, and then that is unbounded. But we have what we are referring as a definite integral, although I did not cover the topic for definite integral anymore. So I hope to, uh, or for you just to learn that one as we proceed to the actual application of definite integral. So remember that, for example, we want to find the integral of a certain function. So we can do that one graphically. So to show, so what does it really mean? So let's say we are given the x and y coordinate. And then, so let's say we want to find the integral of a certain function whose graph would look like this one. So let's say this is an f of x graph. And in indefinite integral, so we just simply, so to find the integral of that, so that would just be simply, so finding the integral of the given function of x, so with respect to x, and that is what we are referring as the indefinite integral. However, if we want to evaluate the given function, here the integral of a certain function, so from using a certain boundary, so that means there's a lower limit and the upper limit, or the lower boundary to the upper boundary, we can do that one, and that is what we are referring as the definite integral. So let's say I just want to evaluate the function, okay, so from the lower limit a, and then this one would be the lower limit b. So that means if I, once I got the interval, okay, so that is from lower limit a to upper limit b, and then integrate it first, and then afterwards evaluate it from lower to the upper limit. So in reality, so what I'll be getting then would just be the area of this shaded region. So that means the exact value that I'm going to get. Okay, so after evaluating the definite integral, so correspond to the area, okay, so of this given region, so which is bounded by the curve and the x-axis, so together with the lower limit and the upper limit. And that is actually the main application, or one of the application in of integration. Okay? So the indefinite integral of a certain function corresponds to actually the area. Okay? But if it is a three-dimensional, so that corresponds to the volume. Okay? So those are two of the main applications in integration. And what is Wallis formula? So Wallis formula is used for definite integral. However, it is very particular to product of sine and cosine. Or it could be just a sine, or it could just be a cosine. So in using the Wallis formula, we have to make sure that the integral so uses this format. Okay, so this should be the format. Although we can make this one as just simply sine or just simply cosine, or a product of sine and cosine. So that would still be okay. But again, it's only for sine and cosine. So we cannot use it for any other function. And at the same time, so the lower limit, okay, so the lower limit should be 0 and the upper limit should be pi all over 2. Okay, so there are certain instances that the given integrand is not the same as this format. However, we can transform it to be in this form. Okay, so on our succeeding example, so we'll be able to do that one. Okay, so for the Wallis formula, so this is how we are using the formula. We just take the product, okay, so just take the product of the exponents, okay, so involved. So m here corresponds to the exponent for sine, and then the power for the cosine is n. And in here, so this term so correspond to sine, okay, or m, and then this is for cosine, and then this one would be the sum of the exponents. Okay, so let's say we have a 6 for m and a 7 for n. So how do we use the formula? So in using the formula, so I'll start with 6. So as you can see here, this is m minus 1, wherein 6 is m. So therefore, 6 minus 1, that is 5. Then multiply it with m minus 3. So m minus 3, that will be 6 minus 3, that is 3. And then the series will be m minus 1, m minus 3, m minus 5, m minus 7. It will be add. Okay. So in short, there's just actually a difference of 2. So instead of remembering that, so what you just need to remember is, so we subtract 1 first. Okay, so from the exponent, so since that is 6 minus 1, that will be 5. And then the succeeding product, so we need to subtract 2. So that will be 5 minus 2, it's 3. 3 minus 2, that will be 1. And then we end up, it's either we end up with 2 or we end up with 1. Okay, so if we have 1, so we stop. If we have 2, we stop. So that is 5 times 3 times 1. So how about for 7? So for 7, that is 7 minus 1, which is 6. And then succeeding, we subtract 2. So 6 minus 2 is 4. Minus 2 is 2. So since it's already 2, so we stop there. So we have now the product of 5, 3, 1 and 6, 4, 2. So that is for the numerator. So for the denominator, we need to add first. Okay, so that is 6 plus 3, which is, or 6 plus 7, which is 13. Okay, so we start then right away at 13. Okay, so for the denominator, so we'll start it with 13. And then the succeeding product, or the succeeding sequence will be subtract 2. So 13 minus 2 is 11, minus 2 is 9, minus 2 is 7, minus 2 is 5, minus 5 is 3, minus 3 it's 1. Until we ended up to either 2 or 1. So that's how we use the formula. And the last thing that we need to recall is A. Okay? So take note of this, that when m and n are both even, okay, that's the time that we multiply it by pi all over 2. Okay, so if both are even, otherwise it is 1. Okay, so what are the otherwise? Okay. So meaning, let's say we have m and n. So let's say m is even, n is even, so we multiply pi all over 2. That's the only thing that I need to remember. Both are even, so it's pi all over 2. But let's say m is even, n is odd. Let's say n is odd, n is even. And let's say m is odd, n is odd. So all of this, we just multiply 1. Okay, so that is our alpha. So this would be our alpha then. So if both are even, that is pi all over 2. And then otherwise, so that will just be 1. So that's how we use the Wallis formula. And then we just multiply everything and divide it with the denominator. So take the lowest term. So that would be our final answer. Okay, so in evaluating the given integrand. Okay, so for our first example, so to get used to it, but of course, I want you to appreciate first, okay, so Wallis formula. So instead of right away using the formula, so let me try to solve this one using the longer method first. So in evaluating a definite integral, so the first thing that we need to do is to integrate it first. Okay, so that will be from 0 to pi all over 2. So the integral of sine cube x dx so can be done using transformation. So remember the trigo transformation, I can make this one a sine squared x times sine x dx. So sine squared and sine x, that is sine cube. And then afterwards, so transformation can be done so using identities. So identity for sine squared, that is 1 minus cosine squared x. Then multiply it with sine x dx. And then after, so we distribute. So 1 times sine x, it's sine x. And negative cosine squared times sine x, cosine squared x, sine x. Then multiply it with the x. Then we can now integrate this. So sine x can be integrated, so that which is negative cosine. And cosine squared x and sine x so can be integrated using power rule. So making our u so to be cosine x. And then once we derive it, so du then will be equivalent to negative sine x dx. And we could have a neutralizing factor of negative 1. So that's from 0 to pi all over 2. So we'll have, so the integral of sine x, it's negative cosine of x. Then minus, we have a neutralizing factor of a negative 1, so that makes it positive. And then, so power rule, so cosine squared, so 2 plus 1 will be 3 over 3. That is just simply 1/3 of cosine cube x. So by the way, we integrated it already, so therefore, we move the boundary, okay? So we move the boundary at the last part. So this is how we do this one. So if it is already integrated, in this case, this is already the integral. So we don't write the plus c anymore. That will be from 0 to pi all over 2. And then we substitute. So how do we substitute? So we substitute x first, or we substitute the upper boundary to x first, then minus the lower boundary. So upper boundary, I'll start with the upper boundary, so which is negative cosine, our x is pi all over 2, and then plus 1/3, so cosine x cubed, so that will be the same as cosine pi all over 2, then raise it to 3. So this is the upper boundary. So minus the lower boundary, we'll have negative cosine, x is 0, and plus 1/3, multiply it with cosine 0 raised to 3. So upper boundary minus the lower boundary. So that is the evaluation of a definite integral. So now, so we can use the calculator. So in defining, so what is cosine pi over 2? So if you want to direct it on your calculator, so pi all over 2 is in radian form. So therefore, you have to make sure that your calculator is in radian mode. But then if you don't want to change the mode of your calculator, which is by default, it's in degrees, so you can just simply convert pi all over 2 to degrees. So how do we convert pi all over 2 to degrees? So that will be multiplying it with 180 degrees all over pi. So pi will be cancelled out, so 180 all over 2, that is actually 90 degrees. Okay, so 90 degrees, so pi all over 2 is 90 degrees. It would appear that we have cosine 90 degrees. So we can use the calculator that cosine 90 degrees is actually 1. Or sorry, cosine 90 is 0. And then the cosine 0 degree, so we have 0 in radian, it's still 0 in degrees. So cosine 0 degree, that will be 1. So you can verify that when using your calculator. So therefore, cosine 90 degrees or cosine pi all over 2, that is 0. So cosine pi all over 2, that is 0. So evaluating the upper boundary, it's just simply 0. But for the lower boundary, so cosine 0, this is 1, while cosine 0 is 1 as well. So therefore, I'll have negative, so this one is 0, minus, so negative cosine 0, that is 1, minus 1, and plus 1 raised to 3, it's 1 times 1/3. So it's 1/3. So which make it negative 1 plus 1/3, it's negative 2/3. So negative times negative 2/3, that is positive 2/3. So we have now a definite answer, okay, so which is 2/3. So that's the longer method. But then how about in so using the power or using the Wallis formula, so that is very direct. So sine cube x dx So remember, the numerator, so we just simply subtract 1, okay? So from 3, so that makes it 3 minus 1, which is 2. And then we end up there, okay? So since the last number should either be a 2 or a 1. And for the denominator, so supposedly it should be a sum of m and n. But in this case, we don't have cosine, so we're assuming that the power of cosine will be 0. So 3 plus 0, that's 3. We'll start with 3, then minus 2, so that will be 1. And what is our multiplier? The alpha. So this is add. Okay, so 1 is add, so therefore our multiplier is 1. So 2 times 1 is 2, so 3 times 1 is 3. So the answer is 2/3. So which is the same as that. Okay. But then we don't need to do that. Okay, so using the Wallis formula, so right away, so we can find the definite integral. Okay, so let's try to get used to the process. Okay, so for example number 2, we have to make sure, so to use the Wallis formula, we have to make sure that first our power or the angle should be a single angle. Di siya pwedeng double angle, triple angle, quadruple angle. If that is the case, we need to use transformation. It's either we're going to use identity, okay, or we could use some substitution. But we have to make sure that our angle there would be a single angle. And at the same time, we have to make sure that the lower limit and the upper limit should be 0 to pi all over 2. Okay, so that is the form. Okay, so for the Wallis formula. So other than that, so there is a need for transformation. Okay, so other than that, there is a need for transformation. Okay, so let's say we have this one. So cosine to the 6x dx. So everything is within the form. Okay. So I'll start with the numerator. So for the numerator, so we subtract 1. So 6 minus 1, which is 5. And minus 2, which is 3. Minus 2, which is 1. So that is for the numerator. For the denominator, so that would be 6. Start with 6 and then minus 2, so which is 4. Minus 2, which is 2. And we retain it. But then, we have our exponent to be odd or even. Okay, so if it is even, I was supposed it should be both even. Okay, so both should be even. So we don't have sign. So we consider 0 to be even. So therefore, so 6. So we multiply it by pi all over 2. And then, so we try to simplify it. So take the lowest term if it's possible. Like for example, 3 and 6. So 6 is divisible by 3. Okay, so that 3 over 6, that's the same as 1/2. Okay, so what remains there will be 2. And then nothing is divisible by 5 nor 2. So therefore, you just have 5 times 1 times pi. You have 5 pi. Divide it with 2 times 4. It's 8 times 2. 16 times 2. It's 32. So 8 times 4. It's 32. So the answer then would just be 5 pi all over 32. So 5 pi all over 32. That is our second example. So for our third example, it's a product this time. Huh? So it's a product again. So this is single angle. Lower limit is 0. Upper limit is pi all over 2. So we're good. So we can use right away our Wallis formula. So we'll have 2. So 2 minus 1. So will be 1. And we'll stop there. So 5. 5 minus 1 is 4. Okay. And then minus 2. It's 2. And we stop there. Divide it with, so 2 plus 5, okay, so 2 plus 5, so 2 plus 5 is 7, minus 2, 5, minus 2, it's 3, minus 2, it's 1. And our multiplier will be, so 1 is add. So therefore, it's just 1. So can we reduce this one? I don't think so. Okay, so 4 times 2, it's 8. 7 times 5 is 35. Times 3, it's 105. So therefore, the answer is 8 over 105. Number 4. Okay. So again, so x and x. So single angle. Lower limit is 0. Upper limit is pi all over 2. Okay, so I'll start with 6. So 6 minus 1, that is 5. Minus 2, it's 3. Minus 2, it's 1. And then for 4, minus 1, it's 3. Minus 2, it's 1. We stop there. And then 6 plus 4, that is 10. Okay. So 10, then minus 2, it's 8. Minus 2, it's 6. Minus 2, it's 4. Minus 2, it's 2. And we stop there. So we multiply it with, so 6 is even, 4 is even. So therefore, so we multiply it by pi all over 2. And then you can do it on your calculator directly. So 5 times 3 times 1 times 3 times 1 times 5. All over 10 times 8 times 6 times 4 times 2 times 2. Then afterwards, so just try to make it equal. Then you'll get the lowest term. But if you want to do it manually, so pwede rin, no? So we'll have a 3 and a 6. So this one will become, so 6 divides 3, it's 2. What else? A 5 and a 10. So 10 divides 5, it's 2. And then nothing is divisible by 3. Right? So 2, 8, 2, 4, 2, 2. There's none. So that will become then, so 3 times pi, it's 3 pi. So 2 times 8 is 16. 16 times 2, it's 32. 32 times 4, 128. 1, 2, this is correct. 16 times 2, 32 times 4, 128 times 2, 256 times 2, 512. So it's 3 pi all over 512. Okay, so 5, 3, 1, so 3 and 1. So 10, 8, 6, 4, 2. So 3 and 6 will be 2, 5 and 10 will be 2. So 3, so the answer is 3 pi all over 512. So 3 pi all over 512. Okay, so in cases like this one, okay, so the first thing that we can see here is, so this is 2x, this is a double angle. And at the same time, okay, the lower limit is okay, it's 0, but the upper limit is pi all over 4. It's not pi all over 2. So what we do here is we transform. Okay? So we change. How do we transform limits? So we can transform limits. So I'll have the upper limit and I have the lower limit. So this is the transformation for the upper limit and the lower limit. So in transforming, so we have to consider the angle. Okay? So in this case, I'm going to, I want to make 2x to be a single angle. So therefore, I'm going to let u to be equivalent to 2x. So we're in, so remember that x is it is where we are substituting the limits, right? So x, it is where we substitute the limits. So therefore, u then, so will be equivalent to 2, our x, so for the upper limit is pi all over 4, right? So 2 pi all over 4, that is pi all over 2. So that is our upper limit. It's actually pi all over 2. So for our lower limit, it's the same thing. So u is equals to 2x. Our x is the lower limit, which is 0, so which is still be 0. So these are the new transformed limits. That is, the lower limit is 0, the other is pi all over 2. But then, so the transformation, so we need the transformation here. So we have dx there, so therefore we need to derive. So our u, so derivative of that will be du, and then derivative of 2x, that will be 2 dx. So u is du, and then 2x is 2 dx. So therefore, du all over 2 is equivalent to dx. And that is what we will be substituting here. So 0, the new limit is still 0. The upper limit from pi all over 4, it became pi all over 2. But that is only true given that we'll have sine raised to 7, our 2x. So this is 2x, which is u. And multiply it with dx. So this is our dx, which is du all over 2. So therefore, so I can move out 1/2. Integral from 0 to pi all over 2. And sine raised to 7 du. And now, it's already in the Wallis form. So we have a single angle, and then the upper limit is 0, lower limit is 0, upper limit is pi all over 2. So there's something just multiplied by 1/2. So what we'll be doing then, so will be 1/2, then multiply it with, using the power, or using the Wallis formula. So 7 minus 1, I'll have 6, minus 2, 4, minus 2, it's 2. Stop there. And for the denominator, that will be 7, minus 1 is 5, minus 2 is 5, minus 2 is 3, minus 2 is 1. So 7, 5, 3, 1. Our multiplier, so since this is odd, it's just 1. And then we cancel out 2. So 6 and 3, 6 will become 2. How about 4? So nothing for 4. So therefore, I'll just have, so 2 times 4 will be 8 all over 7 times 5, 35. So the answer will be 8 over 35. So 8 all over 35. So that's how we do the transformation. Okay. So transformation. Example number 6. Okay. There are multiple flags for this one. Okay. So the lower limit is 0, upper limit is pi all over 4. At the same time, they don't have the same angle. Okay. So we cannot use substitution right away if the angles are not the same. So the thing that we need to do here is we need to make the angle the same first. So how should we do that one? Okay, so to do that, so we need to use some identities. So remember, by the way, before doing that, so I could make this one from 0 to pi all over 4. And then this is sine squared and cosine squared. So what we have is the double angle for sine, but we don't have the square. So since both of them are raised to 2, so we can just move out that power. So this is the same as sine 4t, multiply it with cosine 2t, and then raise it to 2 dt. Okay, so the 2 can be distributed. That makes it sine squared 4t, cosine squared 2t. But then, remember, let's say we have sine 2a. So this is double angle for sine. This is the same as 2 sine a, cosine a. So therefore, if I would have sine 4t, that will be the same as 2 sine. So this is 4. So divides 2, it's 2. So sine 2t cosine 2t. And that is what we will be transforming now. So from 0 to pi all over 4. So sine 4t is this. So 2 sine 2t cosine 2t. So this is for sine 4t. And the other one, we still have the cosine 2t. Cosine 2t. Then raise it to 2 dt. And we combine those. So that would be 2 sine 2t. Then cosine 2t and cosine 2t, that will become cosine squared 2t. And raise it to 2 dt. Then we simplify that further. So 2 raised to 2, that will be 4. So sine squared 2t. So cosine squared raised to 2, that will become cosine to the 4th 2t dt. So we can move out the constant 4. So from 0 to pi all over 4. Then I'll have sine squared 2t cosine to the 4th 2t dt. Okay. So now, we were able to resolve, okay? So the angle, it's now the same, which is 2t. The other thing here is, again, it's still not a single angle, and at the same time, the upper limit is still pi all over 4. So what should we do? So to transform this one, so we're going to use the same idea, just like what we did in example number 5. So we let u our angle. Okay, so our angle is 2t, so u is equal to 2t. So t is the upper limit. Okay, so our upper limit is pi all over 4. So making u to be equivalent to pi all over 2. And then u is equals to 2t. Our lower limit is 0, so therefore u is to 0. Okay, so we're able to transform it from 0 to pi all over 2. Then we derive this. So derivative of u, it's du. 2t, it's 2 dt. So therefore, du over 2 is dt. And let's transform. Okay. So to transform that, so I'll have 4. And then 0. So this is 0. Pi all over 4, which is pi all over 2. That's the new limit. And then the sine squared, so 2t, it's u. So sine squared u, then cosine to the 4th u, and then dt, it's du all over 2. So we can move out 1/2. So 1/2 times 4, that will become 2. From 0 to pi all over 2, sine squared u, cosine to the 4th u, du. Okay, so both of them are in single angle. Then the lower limit is 0, the upper limit is pi all over 2. So it's a format of the Wallis rule. So we can now write 2, okay, then multiply it with using Wallis rule. So 2 minus 1, that is 1. We stop there. So 4 minus 1, it's 3. Minus 2, it's 1. And the denominator will have 2 plus 4, that is 6, times 4, times 2. And then, so since 2 and 4 are both even, so we multiply pi all over 2. So we cancel 2 and 2. So 3 and 6, so 6 will become 2. So therefore, our final answer then, so will be pi all over 2 times 4 is 8, times 2 is 16. So our answer will be pi all over 16. So pi all over 16. Okay, so this is two transformation. So we transform the angle into the same angle first, and then afterwards we transform the limit, so through substitution. So there are cases as well, like for example this one. This is algebraic, and then it is evaluated from 0 to 1 half. Okay, so 0 to 1 half. So 1 minus 4x squared, so 5 over 2 dx. But then remember, so we have triangle transformation. Okay, so this one resembles sine. So a squared minus u squared. So our a here, or a squared, is 1. Our u squared is 4. A is 1, or 4x squared, I mean. And then our u will be 2x. And remember, the one that we will be using, so u is equals to a sine theta. Our u is 2x, our a is 1, so that would just be 2x is equals to sine theta. And then, so we derive this one, so 2 dx is equals to derivative of sine, it's cosine theta d theta. Or just simply dx is equals to 1 half cosine theta d theta. So we can transform it on that way. But then, so how about the upper limit and the lower limit? So for the upper limit, so we can use the transformation as well as the lower limit. Okay, so for upper limit, so this is our assumption. Okay. So we have 2x is equals to sine theta. Okay, so 2x is equals to sine theta. Then x is our boundary, right? So in this case, our upper boundary, it's 1 half. So 2 times 1 half is equals to sine theta. So 2 times 1 half, that is 1, which is sine theta. And then, that is the same as sine theta is equals to 1. So to get the new upper limit, so theta will be equivalent to inverse sine of 1. Inverse sine of 1 is 90 degrees, or pi all over 2. And for the lower limit, so we still have 2x equals to sine theta. Our lower limit is 0. So 2 times 0 is equals to sine theta. So 0 is sine theta. Sine theta is equals to 0. So theta is inverse sine of 0. Inverse sine of 0 is 0. Either 0 degree or 0 radian. So in short, our lower limit and the upper limit are still the same. Or it will become, the lower limit is 0. The upper limit now is pi all over 2. And then we change. So we have 1 minus 4. Remember what is x. Okay. So we can have x here. So x is the same as, or x is 1 half sine theta. So I'll have 4 there. So 1 minus 4. Our x is 1 half sine theta, then squared. So square it and raise it to 5 over 2. Our dx is, it's 1 half cosine theta d theta. So from 0 to pi all over 2. So I'll make this one 1 minus 4. So times, so 1 half raised to 2, that is 1/4. Then sine squared theta. And raise it to 5 over 2. So times 1 half cosine theta d theta. And this is 0 to pi all over 2. So we can cancel this one. So 4 and 4. So it will just become 1 minus sine squared theta raised to 5 over 2. Let me move out the 1 half. So it will become 1 half cosine theta d theta. And then, so I'll have 1 half from 0 to pi all over 2. So 1 minus sine squared, that is cosine squared theta. And 5 all over 2 cosine theta d theta. So 1 half, so 0 to pi all over 2. So cosine squared, then raise it to 5 over 2. So 2 and 2 will be cancelled out. So I'll just have cosine to the 5th theta times cosine theta d theta. So now that will be 1 half 0 to pi all over 2. So cosine to the 6 d theta. Cosine to the 6 theta d theta. At this time, theta is a single angle. So 0 to pi all over 2. So we can now use the Wallis rule. So to do that, so I'll just have 1/2. So multiply it with, so cosine to the 6. So minus 1, I'll have 5, a 3, and a 1. And at the denominator, so that will be 6 times 4 times 2. And then of course, so multiply it with, so this is even, so pi all over 2. So I have 3 and a 6. So this will become 2, 5, so 9 anymore. So I'll just have 5 pi. Divide it with, so 2 times 2, 4 times 4, 16 times 2, 32. 32 times 2, 64. Right? So 2, 4, 8, 16, 32, 64. So the final answer will be 5 pi all over 64. 5 pi all over 64. And that's it. You can review the notes. Good day.